The Sun is entering a stage known as a solar or Maunder minimum. This is where the solar activity that ignites solar flares or sunspots has decreased. It's a normal cycle and one that has been linked to the mini ice age that lasted for more than 50 years, starting in the mid-1600s. According to the website Space Weather, since 2015, the number of days without a recordable sunspot has been rising year over year. NOAA, NASA, and others all appear to agree the Sun is entering a solar minimum phase. What it means is open to interpretation. Because as Professor William Happer pointed out when I asked him about the growing number of people and agencies that suggest a solar minimum could lead to a cooling off period, he directed me to the Danish proverb, "It's difficult to make predictions, especially about the future." In other words, be careful how you interpret this. Now, it has been suggested that mathematics can establish patterns and back them up with empirical evidence to support a prediction. We reached out to Professor of Mathematics Valentina Zharkova of Northumbria University, one of the first people to raise awareness of the decrease in solar activity, for a conversation that matters about the Sun, its reduced activity, and her reading on the impact it will have on temperatures on Earth.
Conversations That Matter is a partner program of the Center for Dialogue at Simon Fraser University. The production of this program is made possible thanks to the following and viewers like you. Please become a patron at conversationsthatmatter.tv.
Good morning from Vancouver.
Good morning.
Before we get started, maybe you could tell my audience what the work is that you do in relationship to the solar cycles that the Sun goes through, and then let's talk about where we're at and what you foresee the future looking like as far as activity on the Sun.
Yeah, so I'm applied mathematicians who did degree in mathematics and physics, applied math and physics, and PhD I did in solar physics. So I slowly converted doing any mathematics for solar physics. And I started doing solar activity in 2002 when we got European grant, European grid of solar observations with 10 other partners, 8 from Europe and 2 from America, when we did automated pattern recognition on solar images and obtained big catalog of solar features, sunspot, active regions, and so on. So after 3 years, we built up these beautiful catalogs, and suddenly we got into this research of solar activity. While before I was doing particle acceleration, transporting solar flares, and different kind of different spectral lines interpretation. So, and from 2002, I started looking at the general solar activity, and we thought when we automatically detected all the sunspots, we can improve the solar activity index defined by the sunspots, because we have everything you can extract from digital images, which allow you possibly to have much better understanding, and you can forecast it for the future. And when we started doing statistical analysis of this data, we discovered that we have all the data. We have 20 parameters on every tiny feature like sunspot, everything you wish. We derived all the laws which were known, Hale law, Jaw's law, whatever, variation of tilt and polarity, but we didn't become closer to forecasting activity for longer periods. And this is when curiosity kicked off. It's about 2006, 2007. We started looking for something else, for some other proxies, and this is how our research started on solar activity. So basically, general solar activity research I'll do from 2002 now till now. It's about 17 years. But there were different phases of it. That I think breakthrough was in 2008 when we discovered that magnetic field inside sunspots correlates or anti-correlates with the background magnetic field of the whole sun. This was very interesting discovery because it allowed you to look at the magnetic field of the whole sun, which has much more data. You have the whole solar disk covered with magnetic field. You split it into the latitude bands and can extract magnetic field in each latitude. And there are much more data than tiny sunspots, sometimes a few tens, sometimes a few units. So this gave us a little bit more data, and we hope will give us a little bit more accuracy. This is how, and we published this paper 2008, and after that we decided, let's go with the background magnetic field, and decided to apply principal component analysis then.
So it's my understanding that there are 3 magnetic fields within the sun.
Yes, so the sun has this ocean. In our planet, ocean is water, and sun planet is a background field. And in this background field, you have those loops which are embedded in this ocean, sitting there, and the places where they're embedded, to us, from our side, seem like sunspots. So sunspots, these are the roots of the loops, which are hanging above the sun but embedded into the surface of the sun.
I got to get you to hang on for a second while we take a quick commercial break. We'll be right back. Conversations That Matter is brought to you by Odlum Brown, a client-focused investment firm that starts client relationships with straightforward conversations focused on you, your aspirations, and your investment priorities. Odlum Brown has been a supporter of Conversations That Matter from the day we started this show. Their only condition was that we provide a non-biased conversation with people from all sides of all sorts of issues. And of course, we couldn't produce this show without the support of Oh Boy Productions. If you're looking to produce a show like this one, I suggest you reach out to Oh Boy. They can help you produce it, and they can help you build your audience. And we also need your support. I ask you to please pledge $1 per show by going to conversationsthatmatter.tv/donate, because those dollars add up and play an important role in helping us produce this show. Now, back to the show. So, in reading material that you have distributed already, it's my understanding that the level of activity of those magnetic fields changes, and it happens in a cycle. And those cycles affect sunspot activity.
The cycles of solar activity are first defined by the appearance of sunspots. So, during the minimum, you have little sunspot, if none. And then during the maximum, you have a lot of sunspots, sometimes large amounts. And then towards the next minimum, the number of sunspots decreases. So previously, people had only sunspots themselves. But because, as I explained you, we did automated recognition, so we extracted also magnetic field of the sunspot, which nobody else did before. And we decided to compare the magnetic field of sunspot groups, which presented, and the magnetic field of surrounding background sun. And we discovered that actually they're in antiphase. So if leading polarity is northern, the background field has to be southern. We discovered that Stix, German scientist, in 1976 already had this discovery. He found that magnetic field comes in antiphase. He did a lot of measurements and shown that they have this 11-year phase difference between a magnetic field of the sunspot and active region. So we were very encouraged that what we discovered, actually people who did solar dynamo before also seen. And we also ran correlation between this background field and sunspot and discovered that very strong correlation coefficient between their features, occurrences, and some biennial periods of 2.5 years. At that time, we only investigated whatever happened within 11-year cycle. But the 11-year cycle, you can say it could be 22 years because the leading polarity changes every 11 years. So technically, to return to the same leading polarity, you need to have 2 of those 11-year cycles. So then next time you return to the same leading polarity in each hemisphere.
So, and with those increases and decreases, well, then we see a difference in sunspot activity. Is that correct?
Yes, yes.
It's my understanding that when we see that increase in sunspot activity, otherwise known as a coronal mass eruption or a solar flare, depending on how you describe it, being the outcome, that what is happening then with those eruptions, that the sun is emitting extra amounts of solar radiation out into the solar system.
What is happening, this background field, which people call it poloidal field, so this ocean in which these loops are floating, called poloidal field, and the loops are coming up, they also carry this magnetic field. This field is called toroidal field. And they come on the surface, and everything would be fine if the sun wouldn't have this differential rotation. So rotation near the equator is much quicker than rotation near the poles. What happens
Right.
that these loops are not following exactly. They start twisting and running behind the sun. So basically they twisting and create a lot of toroidal field, and this is what causes increase of solar activity and increased number of sunspots, and increase of this, like you said, coronal mass ejection, solar flares, and obviously radiation coming with this. And this is because these loops on the surface, they carried by the sun, they make them twisted, interacting each with other. And because interacting, it is like a electric shock in the wires. They produce a lot of energy because the shock, they produce this discharge, boom, discharge, and emission comes to everywhere in the interplanetary space, including the Earth.
So it's my understanding that at the core of the sun, the temperature is about 17 million degrees Celsius. But on the photosphere, it's about 5,800 degrees Celsius. Is that approximately right?
Yes, it's a average temperature of this orange sun is about 6,000 degrees Celsius at the temperature of
And it stays pretty constant, does it?
not exactly. This there is a huge from the core of the fusion reaction fuses the sun. There is a strong radiation zone in which the radiation comes until it reaches the convection zone, and the bottom of the convection zone where these loops, which became later sunspot, are formed by solar dynamo. So the temperature is changing passing through this radiation zone. So it decreases in the convective zone. It will be not 17 millions, it will be lower, still not as at the surface, but much lower. And these loops, which are formed at the bottom of convection zone, they start traveling from the bottom to the surface, and they travel approximately 5.5 or 6 years. So basically all the activity which you will see in the maximum is formed at the bottom of convection zone at the previous minimum. So the loops should be formed before, and they travel whole 5.5 years and then appear, and these loops on the surface which become twisted and shared by the differential rotation.
Okay. So where do you think we are right now as far as what that activity is, and ultimately what it will mean with regards to the amount of energy that will be arriving here on Earth? Will it change the dynamic of temperature on the Earth as a result of this change? Because much has been made about changes in solar activity and its relationship to temperature.
Yes, normally increase of activity, if you go and look at the variations of temperature on the Earth, they follow the solar cycle as well. During the solar maxima, temperature on the Earth slightly increased. During the minima, it is decreased, and they follow nicely 11-year cycle. So definitely we have some.
But it does lag, does it not?
Yes, yeah. It is not linear interaction
No.
because it just come up simply. The Earth responds if you have more heating. Whatever processes are acting on the Earth, they will have more heating, and they have to respond to this heating. So this they will done anyway. What will happen? What is happening with this grand minimum, like Maunder minimum? As I said, there are two waves, and they interfering with each other, and they can have constructive interference when the amplitude of the waves increases. When they
Yes.
in the phase amplitude increases nearly summation of them twice, so it was very strong, nice activity. But because these waves are a little bit off phase, so one wave has slightly different frequency than another, not much, not huge difference. So one wave keep running away from another until they reach the stage when they will be in the stage of disrupting interference. So the one wave has maximum and other wave has minimum. Then these two waves, when they added together, the resulting wave will be nearly zero, very small.
Yes.
And this is what we are heading in grand minima.
So where are we in that cycle right now?
We are exactly at this stage when we are entering modern grand minimum from 2020. For next 33 years, for next 3 cycles, we have first grand solar minimum, and we will observe it from the front seat, all of us.
So what do you think that the impact of that will be, based on your calculations, on the temperature on Earth?
We look at the calculation of this temperature by Lin et al. They have a number of papers, and they shown that the temperature on the Earth during the Maunder minimum and irradiance was decreased about 0.3%. Small amount,
me?
but it is
by-
about 0.8 degrees. The temperature was decreased. Average in England. I look at the variation, which is a huge amount. Which historical records show that during the Maunder minimum in 17th century, the main rivers in Europe were frozen, and people skate in them. There were a lot of snow and so on. So this what decrease of this kind of means. So what we expect for the modern grand minimum, the decrease of the temperature will be slightly smaller than it was during the Maunder minimum, because Maunder minimum we were at the minimum also of the oscillation of the baseline magnetic field. So from 17th century till now, the temperature increased by about 1 degree because of the position of the sun. So if this temperature will decrease 0.8 degrees or whatever, still will be much higher than it was in Maunder minimum. So it will be probably not as cold as it was Maunder minimum. That still will be cold, and still will be not necessarily next 11 years, but between cycle 25 and 26, the least active cycle will be cycle 26, when this disruptive interference occurs. So between cycle 25 in 11 years and 26, and between cycle 26 and 27, this will be the most cold period on the Earth, and probably we would feel it with the lack of vegetation period, enough vegetation period, fruits, vegetables, and so on, heating. Even now, I don't know if you heard, but it was snow on the 7th, 12th, and 14th of July in Carpathian Mountains in Romania and Ukraine. And in July, they never had it for 150 years, snow in July. Also, probably you heard about this hailstones in Mexico, which put hailstones 2 meter high, which also
Yes.
fell down. And similar when we had the Tour de France, the competition,
That's
they
right,
also
had
have
to-
huge
they-
hailstones in there. So these are the first signs what might happen. And 25th cycle will not be the lowest one. It will be slightly lower than 24th, but it already started showing up.
So you see that we're already starting to feel the effect of this.
Yes, we started feeling effect. I've been contacted by people, biologists from Greece and meteorologists from Finland, and they're reporting that in Greece, vegetation period in many trees and different bushes, it starts now 1 month later. So the nature feels that the solar magnetic field is decreasing. So we don't feel, we argue with each other, but nature somehow knows what is going on. So they start in later. So they start in flourishing later. They do not put the first things, first leaves, not in March, probably in April. So this is what say this. Nature feels it when magnetic field decreased, and it's happening already.
I know that you're on record as saying this is not related to anthropogenic carbon, that we still need to address the amount of carbon that we are
Absolutely, I
putting
agree.
into the atmosphere, that these two are not directly related, but this may give us an opportunity, a little bit of extra time to start to address issues related to CO2.
Yes, indeed, because what we explained in our recent paper, for example, we explained the baseline oscillation of the terrestrial temperature, like what is the middle lane of the cosine function. But the temperature increases above and decreases beneath. And whatever increases above, it increases more than people expect, probably coming from carbon or others. This has to be addressed. This has done, we didn't look at it. So we leave to the specialists who do it. We do not object, this is existing. So they do it, it's fine. What we are saying that the sun does its bit, but we do our bit as well. And we need to be more protective and thinking more about how to preserve the planet for the future generations.
Thank you very much for sharing this information with us. It's been something that I've been fascinated by since I first came across your work 4 or 5 years ago, and have been keen to have this conversation with you. So thank you very much for taking the time to do it.
You're welcome.